Hello students, in this video we are going to study about the installation and operation of windmills. So we will see the introduction. Wind is the movement of air from an area of a high pressure to an area of a low pressure. We know that the wind exists because the sun is unevenly heating the surface of the earth. As the hot air rises, cooler air moves into the voids. As long as the sun shines, the wind will blow, and the wind has long served the power source to the humans. So we are aware that the ancient mariners used the sails to capture the wind, and the farmers once used windmills to grind their grains and pump the water. Today, more and more wind turbines bring electricity from the breeze, that is the wind. Over the past decade, wind turbine use has increased more than 25% per year. Still, it only provides a small fraction of the world's energy. Now we will see about the windmills. The number of different options were tried when the modern wind turbines were first built. Today, the universal mechanizing principle is to operate the turbine by using just three blades placed around a rotor which is connected to a shaft. The variations have been tried with two blades and even one blade, but the three blades works the best. As its name states, the windmill's only source of energy is derived from the wind. The wind turns the blade which spins a shaft in turn prompt a generator to produce the electricity. These blades are connected to the generator sometimes through a gearbox and sometimes directly. The generator converts mechanical energy into electrical energy. Interestingly, most modern turbines turn in a clockwise direction. Depending on the wind speed, most modern turbines can operate at speed from little as 4 meters per second to as much as 15 meters per second. These windmills are also called as the wind turbines. Once the turbine's blade turns a shaft located inside a box which is placed on the top of the turbine, gearbox mode is propelled and the speed rotation is given off. A transformer within the turbine then converts the electricity into a voltage which is suitable for the distribution to a national grid. Now we will see the working. The majority of the wind turbines consist of three blades. They are less common varieties with two blades. At 100 feet or more above the ground, the tower allows the turbine to take advantage of the faster wind speed found at a higher altitude. The turbine catch the wind's energy with their propeller-like blades which act much like an airplane wing. When the wind blows, a pocket of low pressure air forms on one side of the blade. The low pressure air pocket then pulls the blade towards it, which is called as the lift. The force of lift is stronger than wind's force against from the side of blade, which is called as the drag. The combination of the lift and the drag causes the rotor to spin like a propeller. A series of gears increase the rotation of the rotor from about 18 revolutions per minute to roughly around 1800 revolutions per minute, and this allows the turbine generator to produce electricity. Now we will see the types of windmills. They are basically horizontal axis turbines and vertical axis turbines, and there is variation of the size of wind turbines also. Small wind turbines that can power a single home and may have an electricity generating capacity of 10 kilowatts. The largest wind turbines in operation have electricity generating capacity of up to 10,000 kilowatt and more. These large turbines are grouped together to create a wind power plant or a wind farm that provides power to the electricity grid. Now we will see the first type of a windmill, that is the horizontal axis turbine or a horizontal axis windmill. They have blades like an airplane propeller and they commonly have three blades. The largest horizontal axis turbines are as tall as 20-story buildings and have blades more than 100 feet long. They are taller turbines with longer blades generating more electricity. Nearly all the wind turbines or the windmills currently use horizontal axis turbine. Now the vertical axis turbine. They have blades that are attached to the top and the bottom of the vertical rotor. So this is the image of the horizontal axis wind turbine having three blades and a shaft. Types of windmill again. So this the vertical one, the vertical axis turbine. It is also called as a Darius wind turbine, which looks like a giant two-bladed egg beater. The versions are that it is 100 feet tall and 50 feet wide. Very few vertical axis wind turbines are in use today as they don't perform well as the horizontal axis turbine. So this is the image of the vertical axis turbine. Installation of the windmills. So the installation starts with the design work by our expert wind consultant and to produce the site layout. This requires a topographical survey and to determine the ground features and levels that will affect the construction process. Also, a geotechnical survey is done to determine the ground condition and to design the foundation and to check whether the ground resistivity is proper for earthing. And then this information is used to determine the location of the main items such as the turbine center, wind turbine transformer, and the high voltage substation if it is required. Once the location of the main items are fixed, the on-site electrical distribution can be designed and the cable trenches and the roads will be specified. This is how the setting up of the foundation of the wind turbine or the windmill is done. See, this is the foundation, cable trenches. These are the delivery of blades. These are the blades for the windmill. Delivery of the lower tower. The blade is getting fixed. Turbine generator. Wind turbine. Then the upper tower section of the windmill is being erected. The lower section of the windmill is being lowered. Then this is the section of the lower and the upper tower section which is being getting together. Then lifting up of the upper section of the windmills is done by the crane. Installation of nacelle where the blades are being attached. Turbine generator has been lifted. See here it is lifting up of the turbine generator. And this is the view of the turbine tower from the inside. And here the turbine generator is being attached to the nacelle. And this is the completed installation of the windmill. Here the in the turbine generator, the blades are attached where it transfers the mechanical energy to electrical energy. Now the applications. The large wind turbines are most often used by the utilities to provide the power to the grid. They are often grouped together in the wind farms to produce large amount of electricity. The wind farms can consist of few or a hundred of turbines providing enough power for the 10 or thousands of the homes. The small wind turbines up to 100 kilowatts are typically close to where the generated electricity will be used. They are also connected to diesel generator, batteries, photovoltaic systems. These systems are also called as hybrid grid systems and are typically used in remote or grid locations where a connection to the utility grid is not available. Advantages: the it is clean and environmentally friendly fuel source. The noise and visual pollution are both the environmental factors, but they don't have a negative effect on the earth. It is a renewable and sustainable type of energy. So, as long as the sun shines and the wind blows, the energy will be produced. It is cost effective. As we are aware that the wind energy is completely free, there is no market for demand and supply of wind energy, and it totally depends upon the wind resource and the particular project financing. Installation of the industrial and domestic need. So it can be built on the existing farms where most of the best wind sites are formed, and also it uses only a fraction of land, which causes no trouble in the work for the farmers. Job creation. This has also created job which is for the manufacturing of wind turbines, installation and maintenance of the wind turbines. Disadvantages: fluctuation of wind and good wind sites. This is a drawback as it is not constant and the wind fluctuates throughout the day or month. This can cause a serious problems for the wind turbine developers who will often spend significant time and money investigating whether the site is particular or not. Noise and aesthetic pollution. The wind turbine generates noise and visual pollution and it can be heard hundreds of meters away. Many people like the look of the wind turbines, but others do not like and they see them as the blot of the landscape. Threat to wildlife. Birds have been killed by flying into spinning turbine blades. However, it is believed that the wind turbines pose less of a threat to wildlife than other man-made structures such as cell phone masts and radio towers. And the fourth disadvantage is that it is not a profitable use of land. Alternative uses for the land might be more highly valued than the electricity generation. So this was all about the solar power plant. So this was all about the windmills, that is also called as the wind turbines. We have seen the advantages, disadvantages, working, operation, installation, that how the windmills is been placed. Thank you.